Good morning. You've got a big one today, 13 videos from the last 25 hours, covering everything from the coding is solved, debate and multi-model AI agent harnesses, to a $7.5 billion acquisition that might redefine how startups are built, a GTA 6 hack spiraling into full corporate warfare, and a cosmologist reading poetry on the TED stage. Grab your coffee, this is going to take a minute. Let's start with the big intellectual dust-up of the day, which Theo, the T3, GG guy, was clearly relishing even though he opened with mild reluctance. The whole thing kicks off with Boris Cherny from Anthropic tweeting, "Coding is solved, bugs are not yet solved, fix incoming." This was in response to someone named Peter posting a screenshot of a visible bug in the Claude Code desktop app. The update notes were getting truncated because a model wrote them without accounting for the actual window size available to display them. Boris then doubled down by calling it not a bug, but a UX issue, which is where Theo pushed back publicly, writing something like, "By what logic would you say the text being cut off in all reasonable display sizes isn't a bug? I'd be really curious what your definition of a bug is." Matt Pocock, for his part, described Boris's original tweet as, and Theo read this with obvious delight, "a raspberry ripple of bullshit, a vanilla ice cream of VC funding, stirred with a little pinch of turd." Theo loves that quote. He thinks it's fair. But he also thinks both Boris and Matt are actually talking past each other because they mean completely different things by the word coding. So Theo's whole video is an attempt to defend Boris while simultaneously agreeing with Matt's frustration, and it works better than you'd expect. He lays out a spectrum of what coding could mean. At the narrowest end, it's literally hands-on keyboard, characters appearing in an editor. Slightly wider, it's turning a Jira ticket into a pull request. Wider still, it's the full cycle from rough idea through working, reviewed code. And at the widest, it's everything an engineer does from the moment they walk in to the moment they leave. Theo's argument is simple. If you use Boris's narrow definition, yes, coding is solved, AI can reliably take a well-specified prompt and produce working code. If you use the widest definition, obviously not. Boris explicitly said he stopped writing code by hand in November of last year, but continues to code daily, using agents, and he called Opus 4.8 the first model that felt like it could code better than him. That's a coherent position once you understand what he means. Matt, meanwhile, cites John Ousterhout's framework of tactical versus strategic programming. Tactical is day-to-day implementation. Matt agrees AI has largely solved that. Strategic is long-term code base health, architectural decisions, the stuff that keeps a system maintainable 5 years from now. Matt's concern is that agents feel like what Ousterhout called tactical tornadoes, people who ship enormous amounts of code with zero regard for the future. Theo partially agrees, but adds a nuance. Agents can be really useful strategic consultants if you ask them the right questions. They won't proactively volunteer architectural concerns, but they'll surface them if prompted. The really interesting section is where Theo builds out his conceptual diagram, plan quality, engineering box, verification layer. The core argument is that verification is the linchpin of the whole system. A good plan plus good engineers still ships broken things, occasionally, without a proper verification loop. And with agents, this is exponentially harder because agents can't see the UI unless you've explicitly set up that capability. He uses the Claude Code desktop app as the perfect illustration. It's an Electron app, so to test it properly in CI, you'd need each test thread running its own graphical virtual machine with a real OS, plus an agent that can control a desktop environment to actually poke at the interface. That's expensive and technically brutal. The web version of Claude, by contrast, runs in a browser. You can spin up 8 parallel test tabs on one machine trivially. That disparity, Theo says, is a big reason why the desktop app lags. He also describes his own T3 code project, where he made thousands of lines of changes just to let the dev server run over Tailskill. So when he's working remotely, an agent can still verify its own work. The meta principle he keeps returning to, if it's hard for a human to verify a change, it's basically impossible for an agent. Agents can't work with their eyes closed. So the practical takeaways are real. Make your code base easy to spin up locally. That's now a prerequisite for effective agent use. Build your verification layer before you scale up agent usage. And when agents hand you work, demand that they show you proof they actually tested it, a screenshot, a video, something, and verify that proof isn't fabricated. Speaking of AI agents and the model landscape, indie dev Dan was in full evangelical mode and clearly energized by what he's calling an intelligence explosion. He rattled off more than 10 significant model releases from roughly the past month alone. Kimi K3, Deepseek V4 Flash, QN 3.8, Muse Glimmer, Nematron 3.5, Grok 4.6, Deepseek V4 Pro, Gemini 3.7 Flash, QN 3.8 27B, GLM 5.3, plus OpenAI slashing prices on Terra, Luna, and testing 50% cuts on GPT 5.6 Sol on OpenRouter. His read on this: the big labs are panicked, pricing wars are in full effect, and for engineers willing to adapt, there has never been more opportunity. His core engineering principle that follows from this is that in periods of rapid technological revolution, the most flexible system wins. If you're locked into one model and that model gets leapfrogged, which is happening every few weeks, you're stuck. So the questions are, how do you use models together to outperform any single one? And how do you build for rapid change so you can always swap in the best performance-to-cost option? He walks through his model tier list pretty thoroughly. At the local lightweight floor, he's impressed with Nematron 3.5 Lightning from NVIDIA and intrigued by QN 3.8 27B, though he wants a mixture of experts variant. Moving up, Deepseek V4 Flash he calls absolutely cracked on pricing. In A tier, he has Deepseek V4 Pro and Gemini 3.7 Flash, and Gemini 3.7 Flash is his declared favorite from the entire explosion. He pushes back on critics saying Google is out of the AI race, arguing Flash represents a deliberate strategic choice to optimize for speed, cost, and intelligence without needing frontier-level performance, and it delivers. In S tier, he puts Kimi K3 and QN 3.8 as open weights, plus Grok 4.6. He also warns strongly against taking benchmark scores at face value. He pulled up artificial analysis and noted QN 3.8 27B scores impressively on paper, nearly matching GPT 5.6 Luna Max, but in actual use it doesn't feel that good, partly due to context window limitations and slow local inference. Always deploy against your specific use case. The main demo is his Fusion Harness V2, which runs 3 agents simultaneously: Claude Fable 5, Gemini 3.7 Flash aliased as Flux, and Deepseek V4 Pro. Important operational note he's emphatic about: never reveal model names to other models in the harness, because if they learn each other's identities, they emit weird behavior. Use aliases only. The use case is exploring DuckDB V2 preview. First command, /FH opinion. All 3 agents run in parallel, answering what the most important DuckDB V2 feature is for a local-first analytics application. Gemini Flash completes first and is blazingly fast. Deepseek V4 Pro runs at around 80 tokens per second. Fable 5 is slowest but most powerful. Fable 5 and Gemini Flash both independently identify the new variant type for automatic structural decomposition at right time as the top feature. Cost for the single run: 65 cents for Fable, 7 cents for Gemini Flash, 5 cents for Deepseek. The cost differential is stark, and it scales with every use. Second command, /FH collaborate, which Dan calls the most powerful command. Given the shared context from the opinion run, all 3 agents first propose plans simultaneously. Then the Fusion Harness selects one architect, always the most powerful model you're willing to spend on, here Fable 5, who synthesizes all plans and assigns tasks. Builders like Gemini Flash and Deepseek get specific tasks with dependencies. The system uses a templated system prompt with T1, T2, T3 notation for cross-agent communication and a to-done list tracking completion. The output is working DuckDB demo scripts. The broader concept he's building toward is what he calls the software factory, not in-loop agentic coding where you sit in a terminal babysitting an agent, but out-loop agentic coding where you build systems that work on your behalf without you. The progression he maps: prompt engineering, then context engineering, then harness engineering like what this video covers, then software factories. He says very few engineers are pushing toward that last stage, and that's where the real alpha is. His quote, "Combine your compute, don't select compute." On a related note, Wendell from Level 1 Techs was also tinkering with an AI agent harness, but his is Intel's SuperClaw, and the vibe is much more relaxed and philosophical. He opens joking about the word claw appearing everywhere, the software, the device, the action, and then gets into the actual demo. He used SuperClaw to install a Linux kernel module on an MSI Claw 8 AIX, which is running Linux on kernel 7.1. Valve and MSI recently released a Linux driver for the RGB controls on the Claw 8's controllers, but it targets a newer kernel than Wendell has. Rather than manually compile and troubleshoot it himself, he pointed SuperClaw at the Valve source code, connected it to the device over SSH. He had to set that up manually as prep, and let the agent take over. He's not claiming this is polished or perfect. He explicitly compares the current state of AI agents to the tin, print hello world era of computing, like the original Apple I and BASIC. Nascent, but real. What he finds genuinely interesting is the model routing concept SuperClaw includes. He references a recent video he did on NVIDIA's enterprise approach, the theme being that you don't need to boil an ocean to answer simple questions. Cloud providers are already quietly routing simple requests to smaller, cheaper models while charging frontier rates. SuperClaw brings a simplified version of this to a local mini PC. You can hook up Anthropic, OpenAI, or OpenRouter for frontier models when you need them, and lean on local models for simpler tasks. He's running an Asus NUC Pro 16 with 64 GB of RAM, using about 47 of them. He also has a quad Intel B70 system with significantly more AI horsepower. On that hardware, he can run the INT4 version of Qwen 3.8, which he describes as a fabulous experience. He does call raw AI coding output god-awful AI slop, but the nuance is important. The magic happens when you set up skills, explicit rules for coding standards, project organization, things the agent must never do. With that scaffolding, frontier models produce dramatically better output. He calls this being a cutthroat micromanaging dictator manager, and notes there's no interpersonal friction when the person you're managing is an AI. The philosophical tangent in the middle is the best part of the video. His argument is that the tech industry has never had enough labor. There are always more tasks than hours, documentation always gets squeezed, tests get skipped, full-stack work gets deferred. AI as a labor multiplier addresses all of that, if you can articulate what you want. The RGB driver install is his personal example. He didn't have time to do it manually, but he could hand it off to the agent with low stakes. He also delivers a pointed observation about organizational dysfunction. Projects fail when management believes they have a clear vision, but hasn't internalized the hidden constraints that technical staff understand. AI can amplify that kind of willful ignorance at the executive level. He thinks it'll be self-correcting soon, but flags it as a real problem. Main caveat on SuperClaw: Intel needs to update the available models to more current versions. The Intel Qwen 3 coder model available through it is already dated, but as a toe-in-the-water experiment with local plus cloud agent workflows, he thinks it's worth a look. Staying in the AI model space, 2-Minute Papers was in full celebration mode. What a time to be alive. Energy throughout, talking about Qwen 3.8, and he thinks it might be the most important open AI release of the year. The headline is that this is a 27 billion parameter open weights model, free to download, and it's gotten millions of downloads in under a week. The presenter's central claim is that it can handle virtually any non-frontier task, the broad base of what most users actually need, and that in some benchmarks it holds its own against current frontier models, clearly outperforming systems that cost $1 billion to build just a year ago. Which naturally raises the question, how? So he pulls up the architecture diagram for the previous Qwen version, then shows 3.8's architecture side by side, and his genuine theatrical surprise when he finds them essentially identical is the pivot point of the whole video. Architecture isn't the answer. The answer is training methodology. He describes it as analogous to progressive overload in physical training. The model starts on simple tasks, then progressively harder ones, then multiple tasks simultaneously, and eventually tasks that take days to complete. The difficulty and duration scale up in a structured, intentional way over time. The implication he zooms out to is significant. If you're willing to wait, frontier-level capability may arrive on personal consumer laptops. He credits open science and open research as the engine making this possible, and he closes with genuine warmth toward the community already fine-tuning and experimenting with the model. Short video, but a genuinely exciting point: a 27 billion parameter model running on a powerful laptop and going toe-to-toe with frontier systems is a real milestone. Now for what might be the biggest strategic story of the day. Nate B. Jones was genuinely fired up about Stripe's $7.5 billion acquisition of OpenRouter, and he makes a compelling case for why you should be too. Start with the numbers that don't add up in a normal world. OpenRouter was valued at $1.3 billion in May. 3 months later, Stripe paid $7.5 billion for it, more than a 5x premium in roughly 90 days. Nate's first point is that this deal is different from other inflated AI-era deals. Stripe doesn't sell chips, doesn't train models, has no data center justification for a premium like this. The only logic that fits, he argues, is that Stripe believed the price would be even higher by the time the paperwork closed. Something in Stripe's internal data triggered that conviction. So what does OpenRouter actually do? It gives developers a single access point to more than 400 AI models from over 80 providers. Its weekly token volume has grown approximately 24,000 times since August 2023, doubling every 11 weeks, steadily, for 3 years. The week of August 10th closed at 75 trillion tokens. The following week was pacing above 87 trillion. In the same investor letter announcing the deal, Stripe stated flatly that the singularity began on January 1st, 2026, and that it has been operating on that basis ever since. Nate says you can throw out the word singularity if it bugs you, but you cannot ignore what Stripe is doing strategically. At Stripe Sessions in April, CEO Patrick Collison showed a chart of new businesses launching on Stripe monthly going back to 2019. The pandemic produced a one-time jump, but the line never returned to its old baseline. Then in early 2026, the curve turned nearly vertical, a parabolic rise in new firm creation. A second chart from Will Gabrick showed Stripe's CLI, which had been around for 7 years and used by almost nobody outside a narrow technical audience, suddenly exploding in usage, not because of a product update, but because coding agents discovered it. An interface built for a human developer at a keyboard became a door an agent could walk through autonomously. Nate acknowledges the obvious objection: Stripe's customers aren't a random sample of the economy. They're online, tech-adjacent, disproportionately SF-connected. A regional construction company didn't experience January 1st as a turning point. But that's exactly why Stripe is the right place to look. It's the leading-edge window into where the broader economy is heading. Stripe supports 88% of the Forbes AI 50, processed roughly $1.9 trillion in 2025. What makes the OpenRouter deal so significant is what it completes. Nate walks through what Stripe has been quietly assembling: incorporation and deployment via Stripe projects, usage metering via Metronome, agent-to-human and agent-to-agent payment via Link wallets and the Machine Payments Protocol, an HTTP-based standard for agents to discover that payment is required and execute it, stablecoins via Bridge and Tempo, fraud protection extended to tokens as well as money via Radar, and product discoverability via Stripe Directory. The live demo at Stripe Sessions showed one agent taking a locally running application, reviewing public APIs, deploying it to the internet, and having Stripe projects provision hosting, database, sandbox, credentials, usage tracking, and billing from the command line. The agent then charged other agents $2 for a review service. Agent-to-agent commerce is already operational. What OpenRouter adds is the intelligence routing layer, a market mechanism for deciding which model handles which job based on complexity, price, speed, and reliability. Before OpenRouter, the Stripe stack could create, buy, sell, and move money through agents, but left unanswered where the intelligence itself should come from. Now it doesn't. Nate draws the direct analogy to Stripe's core payments business. Money on the internet was technically possible but operationally miserable, and Stripe turned that complexity into simple API calls. Intelligence is available everywhere but expensive, heterogeneous, unreliable, and constantly repriced. The same pattern, same opportunity. His advice for founders is crisp: the minimum organizational weight required to attempt disruption is collapsing. Find a workflow in an established industry that is expensive, slow, and unpleasant. Use this stack to attack it without needing large capital. Focus on judgment, customer trust, and problem selection, not rebuilding infrastructure. For incumbents, he has 4 diagnostic questions. Where are you making customers wait because your company has to coordinate itself? Where is your price protecting internal structure rather than real value? Where can someone remove complexity and deliver value faster? And how can you turn incumbent advantages into accelerants for new products rather than reasons to protect old ones? He also urges incumbents to audit their agent purchasability immediately. Can an agent discover what you sell, get a firm price, authenticate without a human's credentials, receive usable output, and generate a verifiable receipt? The macro thesis he closes with, token consumption doubling every 11 weeks, is his proposed analog to Moore's law for the intelligence age. Multiple trend lines bending simultaneously means a different era has already begun, and the appropriate response is to update your base assumptions and act on them, as Stripe did by spending $7.5 billion. Zooming out from the strategic AI picture, Stefan Mischuk, Uncle Steph, was in his relaxed, grandfatherly mentor mode answering a viewer question about whether TypeScript still belongs on a must-learn list in 2026. His answer is a measured no, but it's still good, and the framing he uses is more useful than the specific verdict. Stefan's top 2 languages for 2026 are Python and JavaScript. Python for AI centrality, JavaScript for web application dominance. TypeScript he positions as adjacent to JavaScript, not a standalone must-learn. He explains what it actually is for viewers who might not know. It adds static typing to JavaScript, which catches errors before code runs rather than at runtime. Small performance benefit because the runtime already knows variable types, which saves computational overhead. The main practical benefit for most people is cleaner, more maintainable code. He places it in what he calls the need-to-nerd category. You only learn it if a job or project specifically requires it, not proactively. His reason for this filter is preventing developers, especially beginners, from becoming permanent students stuck in tutorial hell and never actually shipping anything. He makes the case that real-world deployments are worth far more than tutorials. Every app deployed, a React app, a full-stack project, a WordPress site, implementing AI workflows for a business client, teaches more than 5 courses. The sequencing advice he gives is practical. Learn JavaScript first because you can start immediately in a browser with built-in dev tools. Then picking up TypeScript afterward takes roughly 10% of the effort it would have required from scratch, because programming knowledge transfers rapidly across modern languages. He also makes a diet and exercise analogy that lands well. Forcing yourself to eat food you hate to lose weight doesn't work long-term. Same with languages, pick the one that makes learning feel engaging, because consistency is what produces results. The most interesting part is where he connects all of this to AI-assisted development. His principle is that AI works best on fine-grained code bases, small, localized, tightly controlled chunks of code and context. AI degrades when given too many things to handle at once. Understanding what TypeScript offers versus JavaScript lets you give AI better parameters and helps you structure projects so AI can manage each component cleanly. He illustrates with a friend who runs a travel services business, knows HTML, CSS, and deployment basics, and has been building a sophisticated app with Claude Code. The key to its success is a well-crafted database the friend built over years with professional developers. It mirrors his business operations and acts as a brain that constrains and contextualizes the AI. Bottom line from Stefan: TypeScript is good, put it on the need-to-nerd list, learn it if it appeals to you, and don't stress if you start with JavaScript first. Shifting gears to the business side, there was a high-energy video from a developer entrepreneur who goes by BGO or Go, laying out what he calls the local celebrity model. And he was clearly in sales mode the whole time, but the substance is real. He opens with a hypothetical. You just got laid off and need $150,000 in 30 days. His claim is that most developers would polish their resume or try a SaaS and fail, and that his model generated over $150,000 in profit in a single month, with close to $250,000 in revenue. The core concept is becoming the trusted tech person that every business owner in your local geographic area knows. And the scale is deliberately small. He's based in Glendale within Greater LA, and he says you don't need all of LA, you just need the business owners in your immediate city or neighboring ones. He argues that only 5 to 10% of local business owners need to have heard of you for the model to generate 7 figures. The logic: AI made code cheap, but it made trust expensive. Because so many people are running AI agency pitches, trust between businesses and those agencies is extremely low. Being a local, known figure is the antidote. Step 1 is getting first clients from your existing network. He says write down at least 30 people who already know you, old coworkers, gym contacts, family friends who run businesses, your dentist, your barber, your landlord. From that list, you reach out with a specific angle. Everyone is talking about AI, but nobody tells business owners what it actually means for them. You're offering a free audit to look at how their business operates and show them whether there's real money in AI for them, and if there isn't, you'll say so honestly. He claims roughly a 20% conversion rate from outreach to audit when applied properly. On the audit call itself, the rule is you don't talk about technology. You ask about the business. How does it run? Where do the hours go? Who does what? What does the customer journey look like? You listen for complaints. Those are the pain points you'll target. And critically, you get paid before you build anything. When pitching, no technical jargon whatsoever. The framework is: name the leak, describe the fix, state the price. No mention of APIs, automations, integrations, AI agents. Business owners don't understand these terms. Frame everything in hours saved, mistakes eliminated, money found. The concept he's most emphatic about is pricing the problem, not your hours. The price should reflect how much the problem costs the client. He illustrates with a real example. A waste staffing company had a broken payroll process, causing man-hour losses and state-issued fines. He priced the custom software solution based on what they were already losing, not on his development time. After the first few network clients, you expand by joining local business communities, Chamber of Commerce he calls a definite must, BNI chapters, Rotary clubs, industry meetups. You attend consistently and let trust build naturally. And the highest ROI activity he identifies is coffee meetings with professionals who serve many business owners: CPAs, insurance agents, bankers, realtors. Each of these people meets with hundreds of business owners a year. His accountant, a popular local realtor, insurance agents, and bankers all carry his business cards and refer clients to him. His math: 5 or 6 such connectors sending 1 client per year each, at mid to high 5 figures per deal, could add $100,000 to $500,000 in revenue without any cold outreach. The scaling mechanics he lays out are clean. Every win gets documented, the proof pile builds and starts selling for you. After each win, you immediately ask who else the client knows with the same problem, offer a 5 to 10% referral fee, and ask the client to write the introduction email themselves. After 5 to 10 projects, you do a 3-column analysis: highest pay, best client result, least friction, and specialize in the intersection. You raise prices every 2 to 3 clients until conversion drops, and you convert project work into monthly retainers, so the month never starts from zero. His math for scale: 20 clients at $5,000 a month is $1.2 million a year, no large team, no ad spend. He's honest in the reality check section. Year 1 is a grind, first few months will involve botched sales calls and failed projects. Year 2 is when it compounds. He then rattles off a long list of code to CEO student results, including Paul at over $50,000 a month in recurring revenue, Benoit with a $32,500 deal extended for another $30,000, and John in the Bay Area, who became the local AI expert for HVAC companies and received a $4.5 million acquisition offer for his consultancy. Quick one from OpenAI. This was a short promotional vignette, maybe 30 seconds, for ChatGPT's voice feature. The scenario is someone in a kitchen or food development context who tastes something, decides version 3 of a recipe is closer but too spicy, and immediately issues a hands-free voice command to ChatGPT. Grab the previous recipes from email and compare with this version, then compile the notes because we need approval by Friday. ChatGPT responds immediately, and the small but deliberate touch is that it opens with "Let's get cooking," a tone-matched contextual opener. It then surfaces the specific finding. Version 3 added ancho, serrano, and charred tomato, and the serrano in particular is identified as the source of the extra spice. The point being made in 30 seconds is that voice interaction with ChatGPT can pull from real data sources like email, compare document versions, summarize findings, flag specific details, and handle multi-part instructions, all hands-free, in natural language in the middle of a task. It's a product demo dressed up as a lifestyle moment. Not much more to it than that, but as a demonstration of the hands-free use case in a messy, real-world context, it's clean and effective. There was also a video from the AI Daily Brief on the future of AI and work, but unfortunately the actual transcript content didn't come through in the notes. What was included was just a placeholder. So I can't give you a proper rundown on that one. You may want to circle back and watch it directly if the topic is on your radar. On a completely different note, Linus was genuinely excited and slightly incredulous about a water cooling build that cost around $230 and delivered better performance than a premium AIO cooler. The value proposition he's exploring is that premium AIO coolers have gotten expensive enough that they now overlap in price with entry-level custom loops, especially from Chinese brands like Bikeski. So he built a full custom hardline water cooling loop, cooling both CPU and GPU using a Bikeski beginner kit, and the result is impressive, though he was candid that beginner is a bit of a misnomer. The test system is substantial. AMD Ryzen 9 9800X3D, 32GB DDR5 at 6000 MTS, NVIDIA RTX 4070 Super in a Fantex case. The GPU block is where Linus argues the real value lies. Decent CPU AIOs can be found for $50 to $60, but GPU AIO options are rare and expensive. Custom loops let you cool GPUs that have no AIO option at all. Bikeski's kit system is smart. You use their reseller configurator to get a kit matched to your specific CPU and GPU, eliminating the guesswork around block compatibility, pump selection, and connectors. The kit includes a triple 360mm radiator, 3 120mm fans, and a combo reservoir pump unit. What the kit doesn't include: a heat gun, deburring tool, silicone bending inserts, and something to cut tubing. Linus used a bandsaw, but says a fine-toothed saw works fine. He walks through GPU disassembly in real detail, keeping screws organized by position, carefully removing thermal pads from the stock cooler, and inspecting the Bikeski GPU block, whose thermal pad placement documentation he describes as essentially non-existent. A bunch of thermal pads, good luck figuring out where they go. His practical method is checking which raised squares on the PCB definitely need a pad, physically lining up the block for recessed areas, peeling both sides of every pad, and using a counting method, 8 points of contact, 7 pads plus 1 paste application. For the GPU die itself, bare die, no heat spreader, he uses thermal paste and stresses full coverage, checking by pressing the block down, pulling it up, and inspecting. For the PETG hardline tubing bending, the technique matters. Apply heat from a heat gun with constant rotation across a wide zone, overbend past 90 degrees and let it relax back as it cools, then cut incrementally because you can always cut more, you can never uncut. They ran 4 tube segments total. 2 leaks appeared at first power on. One was Linus's fault, he hadn't tightened a fitting enough. The second was Bikeski's fault. On their own reservoir, there's insufficient clearance to fully tighten the outer compression collar, so the seal can't be properly compressed. That fitting had to be replaced with a third-party one. He called this not very beginner-friendly, with some genuine frustration. Despite that, temperatures came in strong. CPU at mid-60s Celsius, GPU sub-50 Celsius. He ran full stress tests with Fermark and Cinebench, and found the GPU held the same temperatures under sustained load, confirming the triple radiator has adequate capacity for both CPU and GPU simultaneously. The system runs very quietly. The upgradability argument he closes with is real. AMD has committed to AM5 socket support through 2029, so the CPU block carries forward. Pumps, reservoirs, and radiators don't wear out quickly. A next-gen upgrade would likely only need a new GPU block. So for around $230, higher now due to tariffs and shipping, but still competitive, you get better cooling than a premium AIO, at both CPU and GPU with a system you can expand. While we're on practical tools, Mike from Game From Scratch was in a grumpy but enthusiastic mood covering Pinta, a free open-source image editor that he frames as the cross-platform alternative to Paint, net nobody knows about. The context he sets up: Microsoft Paint is the classic lo-fi option, but Microsoft has been messing with it, most recently adding AI features that fans of the simple original resent. The next rung up has historically been Paint. Net, which sits between Paint and Photoshop, closer to the Paint end, free, handles most casual needs. But Paint, Net has two significant problems. It's Windows only, and its download website is notorious for aggressive deceptive advertising, fake download buttons designed to trick users into installing malware or unwanted software. Mike says he's always hated this about Paint, Net even though he likes the program itself. Pinta, available at pintaproject.com, is the solution. Free, open source, MIT licensed, written in C, runs on Windows, Mac, Linux, and BSD. It originated around 2010 as a spiritual successor to Paint. Net. The demo he runs covers zoom performance. He calls it very performant, all the way down to individual pixel level. He demonstrates the anti-aliasing toggle, which is specifically relevant for pixel art. With it off, you get hard single-pixel placement, with it on the brush rounds edges. He calls Pinta a good choice for pixel art beginners. Filters and adjustments include curves with real-time preview, levels, blurs, distortions, a pencil sketch effect, all with live feedback before you commit. Layers work as expected. Toggle on and off, create new layers, paint independently. More advanced tools: the clone brush where you anchor a source area with control and paint that content elsewhere. The shape builder with filled, outline-only, and combination options, and a line tool with Bezier-style control points where you can draw a line and pull it into a curve, adding control points anytime. Photo editing includes red-eye removal and vignette, both with live preview. He closes by returning to Paint. Net's website to show it's still displaying, his words, a scummy vignette ad trying to get me to download something very suspicious. He also notes approvingly that unlike Paint and Microsoft's suite, Pinta has zero AI or Copilot integration. Pinta 3 was released in April 2025 with multiple updates since. If you need simple cross-platform image editing and want to avoid Paint, Net's download site, this is your answer. For something genuinely different, TED published an interview with cosmologist Mack, conducted by Debbie Millman on the TED Next stage. And it's a warm, wide-ranging conversation that covers aerobatics, a classified Apollo 11 story, the cosmic microwave background, and the 5 possible ways the universe might end. Mack opens talking about her private pilot license and aerobatic training, flying in extreme configurations, loops, spins, rolls. She pushes back gently on being called a daredevil, explaining she's drawn to intellectual and skill challenge, not adrenaline. And there's a practical dimension. Learning extreme aircraft behavior makes you a safer pilot when things go wrong in normal flight. She also describes flying as a rare mental refuge, total mandatory focus that shuts out everything else, including work. Then Millman asks about her grandfather, and this is the story that stops the video cold. He was a Navy meteorologist who worked on satellite weather imaging and was tasked with confirming safe weather conditions at the Apollo 11 splashdown site. Checking standard charts, everything looked fine. But he knew about a classified spy satellite that also functioned as a weather satellite. Using his Navy connections, he accessed it secretly and discovered the designated splashdown zone had an incoming storm system, described as screaming eagle thunderclouds, severe enough to potentially tear the parachutes off the returning capsule. With only 72 hours to splashdown, he had to convince NASA to move the site, but couldn't disclose the classified satellite, so he had to rely entirely on his reputation and expertise to persuade them. NASA agreed but sent aircraft to the original site as a check. The storm was confirmed, the astronauts landed safely at the new site. This was classified throughout Mack's childhood. She only learned of it in adolescence. On her path to cosmology, she picked up Hawking's A Brief History of Time at age 10, admits she didn't understand much of it but pressed through because she wanted to know, and the book introduced her to the word cosmologist. She didn't know such a field existed. She attended Caltech for physics, Princeton for a PhD in early universe cosmology, cosmic inflation, and dark matter. She describes the field as building a mathematical cartoon of the world, taking data and creatively constructing a mathematical machine to connect observations. Highly collaborative, social, chalkboard arguments, constant conferences, not solitary equation writing. On the cosmic microwave background, its microwave frequency light detectable in every direction in space. Its spectrum matches perfectly what you get from a hot glowing body. It's the direct light from the Big Bang era, when the entire young universe was in a hot dense state roughly 13.8 billion years ago. Looking far out in space is looking back in time because light has finite speed. Mack calls this direct visibility of the early universe incredible, and she's also disarmingly honest that she can't actually conceptualize billions of light years any better than a layperson. She works with the numbers as abstract markers without a felt sense of the gaps. On choosing to study the end of the universe, she started with the beginning, moved through cosmic evolution, and wanted the full story. Her book, The End of Everything, covers 5 possible endings. The Big Crunch, where everything collapses, heat death, indefinite expansion into cold equilibrium. The Big Rip, where accelerating expansion tears everything apart. Vacuum decay, where a bubble of a new lower-energy quantum vacuum state expands at light speed, destroying existing physics everywhere it touches. And the Bounce, cyclic models where endings seed new beginnings. Each has worked out physics in the literature. Millman says the Bounce feels most hopeful. Mack agrees, but uses the certainty of eventual cosmic destruction for a personal philosophical pivot. If everything will be destroyed and nothing ultimately preserved, meaning cannot be deferred to some future resolution. It has to be self-contained, found in the present. The video closes with Mack reading her poem, Constructs, on the TED stage. The final lines, "We are not essentially our constituent parts, we are the knowledge that unites them." It's a genuinely lovely way to end. And finally, Yang Ye was animated and barely concealing his glee at the chaos unfolding around the GTA 6 leak situation, which has escalated dramatically. The hacker or hacking group operating under the name CyberLeak appears to possess a full or near-full playable build of GTA 6, believed to be from 2025, based on music within the game dated to that year. They've been drip-feeding gameplay clips to the internet, 11 videos as of recording, and running paid polls asking the community what they want to see next. Options have included Vice City Beach, Strip Club Part 2, and Nudist Town. Nudist Town won and was delivered. One clip ended with the protagonist literally urinating and saying, "I gotta take a leak," a direct taunt. CyberLeak has also spelled out his own name on an in-game wall, demonstrating control over and access to the build. For a while, observers questioned whether CyberLeak actually had comprehensive access because only the male protagonist Jason was shown and female protagonist Lucia was absent. Clip 9 put that to rest. It showed a continuation of a strip club cutscene that confirmed Lucia is unlocked. CyberLeak has simply chosen not to show her yet. CyberLeak launched with a manifesto of commandments directed at publishers, centered on consumer rights. Key demands include a physical disc version of GTA 6 and opposition to locking resale rights away from consumers. Watermark messages in clips include, "They want to take your rights to resell. The peaceful route got us nowhere. This was plotted by them for years. It is time to fight now or never." This framing has won significant community goodwill, because the gaming community already resents Take-Two for locking in-game content behind a $100 deluxe edition, and paywalling their extended marketing look behind a Netflix subscription. The Dead Man's Switch claim is the part that creates a genuine lose-lose for Take-Two. CyberLeak claims to have distributed copies of the build across servers and drives globally, and to be manually canceling their publication every day. If arrested, those cancellations would deactivate automatically, and the full build could leak within days. Yang Ye acknowledges this is unverified, but notes that CyberLeak has fulfilled every single promise made so far. Arresting them could trigger a full game leak. Allowing them to continue means ongoing damage up to launch. There's also a cryptocurrency angle. CyberLeak has been promoting their own coin, also called CyberLeak. When the market cap hit $3 million, reportedly in under 24 hours after being set as a target, CyberLeak released the full strip club clip as promised. The market cap has since reportedly grown to approximately $30 million. CyberLeak burned all developer-held tokens and posted proof to address scam accusations. But a commentator named King Julian pushed back hard, arguing burning dev tokens doesn't prevent a rug pull, and that liquidity pool manipulation and other wallets could still be used for fraud. Yang Ye presented both sides without endorsing either, noting many in the community don't care because they're so opposed to corporate behavior that they're willing to overlook CyberLeak profiting from the disruption. Take-Two's response has been scorched earth and is generating more public sympathy for the leaker than for the company. They won court approval to subpoena Discord and Microsoft to identify CyberLeak, but the Discord subpoena's scope is what inflamed public opinion. Take-Two is pulling personal data, emails, phone numbers, IPs, device IDs from approximately 100,000 users across multiple servers, including content creator Dark Viper AU's server of around 90,000 members, who discussed the leaks as news but had zero involvement in the hacking. Take-Two has also issued subpoenas to Google and X for anyone who spread leaked content, and has issued DMCA notices against accounts that never posted leaked footage. Gameverse reported receiving a DMCA over captions alone, while accounts with actual high-quality leaked clips and millions of views remained untouched. There's also a story circulating about Take-Two lawyers showing up at people's homes, which has precedent from a 2015 GTA 5 modder situation. But Yang Ye flagged this specific story as potentially fabricated. Tom Warren of The Verge dismissed it, and the person who posted it subsequently began asking for money, which one source called a total stunt classic cash grab scam. Yang Ye explicitly told viewers to treat it with skepticism. His overall assessment: despite all of this, GTA 6 will be commercially unaffected. Pre-orders already suggest a historic launch. He called it a generational release that's way too big to fail, and predicted it will be the biggest launch in entertainment and media history. The leaks have functioned as better marketing than Rockstar's own campaign. Common reactions in the comments are things like, the leaks have done more to convince me to buy this game than Rockstar has over their entire marketing campaign. And this is from a 2025 build. The final product will be even more impressive. That's everything from the last 25 hours, a dense mix of AI tooling debates, a startup world reshaping acquisition, a cosmologist reading poetry, a GTA 6 situation that keeps escalating, and a surprisingly affordable water cooling build. Quite the day. You're fully caught up.